Hi everybody, I wanted to make a quick video about the review of combinations of functions and inverses that you may come across as you're taking trig. So as you're doing problems, you may see that we go back to algebra that we used, and I just don't want you to be surprised by that. So I started with combinations of functions, and just to say that they are exactly what they look like. So if it says parentheses f plus g of x, it means you're going to find f of x and add g of x. If it says parentheses f minus g of x, you'll do f of x minus g of x. So same thing, f times g of x, you'll do f of x times g of x, and then f divided by g of x, you'll do f of x over g of x. You do have to make sure that x is in the domain of both of the functions. So if you can't use x for f or g, then the whole thing goes away. And of course, we're not going to divide by 0. So for example, you could have f of x is the sine of x and g of x is the cosine of x, and we may want to find the value of f plus g of 45 degrees. This says we need to know what the sine of 45 degrees is, and we also need to know the cosine of 45 degrees. 45 degrees, sine and cosine are both the same. They are both the square root of 2 over 2, so we can put that in there. Square root of 2 plus the square root of 2 gives us 2 square root of 2. We're dividing by 2. I can cancel that 2, and I end up with the square root of 2. So I found the sine of 45, I found the cosine of 45, then you simplify. We'll do one more. Here I have f over g of 30. So same kind of thing. I would have f of 30, which is the sine of 30 degrees, and then I'll divide by the cosine of 30. The sine of 30 is a half. The cosine of 30 is the square root of 3 over 2. We'll simplify this by flipping. So the square root of 3 over 2 becomes 2 over the square root of 3. I can cancel the 2's. I get 1 over the square root of 3. Remember, we need to rationalize that denominator, so that becomes the square root of 3 over 3. Yes, this is the same thing as tangent of 30 degrees, but I wrote it this way just to show what we would do if it says divide. Another thing that might come up is composition of functions. So composition is written f, this open circle, and then the g of x, so f composite g. F composite g of x says we're going to find f of g of x, and order matters. You're going to do the inside g of x first, and then you'll apply the f of x. Because of that, because of the order, the domain is the set of all x in the domain of g, for which g of x is in the domain of f. Let's look at it. Let's say this time I have f of x is the tangent of x, and I have g of x is 3x. So the first time through I said let's find the value of f composite g of 45. So I have f of g of 45 degrees. So we're going to leave the f alone and look at g. Well, g said multiply by 3, so I'm going to have 3 times 45 degrees. This says I have f of 135 degrees. So we're just doing the number part. Now that we have the number part done, we're ready to apply f. Well, f was the tangent, so I have the tangent of 135 degrees. If you don't have it memorized yet, you could draw it out that this is 90, so right over here, this would be our 135, right, if we did our angle. Well, we know this is another case of 45. Tangent of 45 is 1, but then when I look over into the second quadrant, we have to worry about what sign would it be. So you could do it by just thinking about like what other values do I have. So I have this positive, the square root of 2 over 2. This is the negative square root of 2 over 2. But I had one positive and one negative. Positive over a negative is a negative. So this tangent of 135 would be negative 1. We're going to do it again. This time I'm going to flip it in the other direction and do g composition f. So I'm starting with the f this time. So the f was tangent. So this is tangent of 45 degrees. So the tangent of 45, we just said that was equal to 1. But then g says whatever you have, you're going to multiply it by 3. So I'm going to have 3 times 1, which gives me 3. So I have this big difference in answers between doing f composition g of 45, it gave me negative 1, and g composition f gave me positive 3. So you do want to watch the order. Make sure you're working from inside out. One more thing we should talk about that you're going to see as we're going through a trig are inverse functions. And we'll get really into like sine inverse, cosine inverse, stuff like that. But right now we just want to go back to points that are on an inverse function. So we have this notation f negative 1 of x. And this reminder that if xy is on the graph of f of x, then we're just going to flip it around to yx, and that's going to be on f inverse. So that looks like, say that we had f of x is equal to secant x, and we want to find the point on the graph when x is pi over 3. So we'll start by saying f of pi over 3 is the secant of pi over 3. Well, secant is like 1 over cosine, so if you wanted to do 1 over cosine of pi over 3, cosine of pi over 3 is a half, so I have 1 over a half. This is equal to 2. Okay, now that we have this 2, we know our input, pi over 3, and our output, 2. So this would be the point on the graph of f. The point on the graph of f inverse would be just flip that around. So I put 2 first, then I put pi over 3 second. So it's just a simple flip. You're not doing anything special. You are not finding the inverse function. That's not what's happening. You're just taking your point and flipping it. Hope that helps. We'll continue to review algebra as we go through trig, but I wanted to point out these couple of things that you might see in the beginning.